values method is you first of all look at your domain. So let's assume our domain is all real numbers. You're going to make a table of values. That's this table. Pick a sample from your domain, probably some negative, 0, and some positives, but you get to choose. You find the matching, once you get your x's, you find the y's. You get a set of points, right? You graph them, you connect the points and make arrows based on your domain. So if it's all real numbers, you have arrows in both directions. Or graphs, right? Say yes.
Yeah.
Awesome. Okay. That's the way we know. So now we're going to think about it a little bit differently. We've always been getting 3, 4, 5 points. What is the minimum number of points I actually need to make a line? Why? Yeah, but if I only have 1 point, how many lines fit through there? Well, here's a line, but here's another line, and here's another line, and here's another line. So how many lines can I fit through 1 point? A lot, an infinite number. But as soon as I have that second point, what happens? I'm kind of anchored, right? I can't make a second line, and that's it. So how many points do I need? 2. I only need 2. Okay, so now what we're going to do is say, gee, I only need 2 points. There are 2 points that are actually pretty easy to find. Yeah, there are. We're going to learn about which 2 points they are. So why not pick 2 easy points, graph them, I got my line. So that's the whole idea behind the second method. The second method uses X-intercepts and Y-intercepts. So let's remind ourselves what X-intercepts and Y-intercepts are. An X-intercept is the point where the graph crosses the x-axis, right? So this over here is an X-intercept because here's my x-axis, see my line? It's crossing at point 3, 0 in this example. All right, a y-intercept, this is a point where a graph crosses the y-axis, exactly. So again, here in this example, I'm crossing over here at 0, 6. So if I know these 2 points, isn't it easy to just kind of stick a line right through it? Is it? Yeah. So that's the idea behind this method that we're going to be using. So let's see if we can name them. So I've got a graph here. Can I name the x-intercept? Where is the x-intercept? Well, what's the coordinate? 0, negative 2 is over here. 2, negative 2, 0, right? Start here, go left 2, don't go up or down. That's the x-intercept. What about the y-intercept? Where's that thing? 0, 2. Where is it? 0, 2. That says don't go left or right, that's 0, but go up 2. So there's my y-intercept. So I can see these by looking at a graph very easily, right? Now here's a little bit of a tricky bit that sometimes gets confusing. The x-intercept, which is here, right? Yeah? X-intercept. What's its y value? 0. No, it's not going 0. It's saying don't go up or down, stay on the axis there. And the y-intercept, what's its x value? So x-intercepts have a y value of 0, and y-intercepts have an x value of 0. Is that confusing? Well, sometimes it is.
It makes sense.
It makes sense. Now, let's say you're working with, you're like, which one? Do you draw a picture? Did you draw a picture to get that back? Here's an x-intercept. What's the y value of this point? 0. So I could call this point x, 0, can I? I don't know what x is, but I know y. And then a y-intercept, gee, I can't remember what that is. Let me write an example here. What's its x value? Well, that's 0. I don't know its y value. But do I kind of get that information? X-intercept has a y value of 0. Y-intercept has an x value of 0. Don't let it be confusing. Just kind of draw the picture again. In fact, you kind of need to see it. So we're going to find x and y-intercepts without seeing the picture because we're going the other way. You have an equation, and I want to graph it. So how do I get there? So we're going to use this information here. An x-intercept, right? X, 0. Does that make sense? Why I'm saying this is an x-intercept? It makes sense for you? Who's it? Okay, yeah, I'm following. I just want to see you guys. Just don't know if there's anybody right yet. I'll lose you later, but not yet. this is an x-intercept. So you have some equation, and again we're using ax plus by equals c. I'm using the general form. If I want to find the x-intercept, it's going to be x something x comma 0. Don't I know the y value already? What's the y value? 0. So can I plug that in here? Ax plus b times 0 equals c. To find the x-intercept, because the y value is 0, I'm just plugging in 0. So ax equals c. Okay, x equals c over a. It's already a little bit confusing, but I can solve for x. Because now I only have one variable. Same thing with a y-intercept. Which value is 0? The x value is 0. So if I'm looking at a generic form, I would plug a 0 in for x. I already know half of the coordinate. So that kind of goes away. And then I can solve this thing for y. Don't worry about this part so much yet. The important part is when x is 0, I plug in the 0 to solve for y. And when y is 0, I plug that in and solve for x. So let's use like real numbers. I think it'll make a little more sense. So here's an example I've got. 2x plus 7y equals 28. Is this a linear equation? How can I tell that this is a linear equation? Well, does it match this? This is the standard form of a linear equation. What's a? 2. What's b? 7. And c is 28. So this is going to be a linear equation. So I know that. I want to find the x-intercept and the y-intercept. I want to know where it hits the x-axis and where it hits the y-axis. So I'm going to find the x-intercept. And again, the picture maybe is helpful. I don't know where it is. Let's say it's over here. I don't know the x value of this point. But what's its y value? 0. So I'm going to take this 2x plus 7y equals 28, and I'm working on finding what the x-intercept is. I know the y value. So I'm going to plug that in. The y value is 0. Because that's how our x-intercepts roll. Right? Their y-intercepts are 0. What's 7 times 0? Well, 2x plus 0. 2x, right? That whole term kind of disappears, doesn't it? Doesn't it? Yeah. Okay. So now solve this for x. Divide both sides by 2. What do I get? 14. So the x value is 14. So what's my x-intercept? 14, 0. Yeah. Well, what do you mean subtract 7 first? Well, but I'm put 7 times 0. Right, when you plug something in, you kind of have to do that multiplication, and then you would do the subtraction. But since this is 0, it just disappears. So, and it's why we're choosing these points, because working with 0 turns out to be kind of easy. It eliminates stuff. So that's why, and I said we're going to pick 2 easy points. These really are the easy points to find. So I got this one. Now y-intercept works the other way. My y-intercept is somewhere up here or down there. I don't know. It could be down here. I know its x is 0. I don't know what the y is. I don't know how much to go up or down yet. But I know half of it. I know half of the coordinate. So I'm going to take my 2x plus 7y equals 28. I'm going to say, well, I know what x is. It's 0. So I'm going to plug that guy in. What's 2 times 0? 0. 0 plus 7y. Yep, so it's like that just goes away. And now what's y? 4. So now I figured out what the y is. It's 4. So what's the coordinate of the y-intercept? 0, 4. Who followed? Who has a question? I think you've got it. But she's looking like she has a question. She's trying to think of where might I be losing you somewhere? Is it because I set the y 0 to find the x? Yeah, I mean, that is a little bit confusing. But I like kind of actually writing the coordinate out so I can see. I know half of it already. It's 0. And remember how we find solutions? You plug the x in, you plug the y in. I don't know the x yet. Why this is 0? Yeah. Where that is? Because of an x-intercept, right? What's the y value of any point 0. That's this. So if I want that point, that's my y value. Has to be. And that's why I plug it in for my y. Same thing with this guy over here. What's the x value of anything on here? 0, right? The x value. So I know half my point. So I plug that in and solve for the other. And again, that is the tricky bit. You said y equals 0 to find the x-intercept, x equals 0 to find the y-intercept. And really, what are we going to do with these values? Well, 14, 0, I'm going to plot it, probably up here. And then I'm going to plot 0, 4. Can I make a line? Yep. And I can plot fairly easily once I find these. Yeah. Because this way is easier than the other way.
No, so why do we learn this first?
What?
Why do we learn this first?
Were you ready for it first?
No.
This is just for intercepts.
No, what if it doesn't have an intercept?
That's a great question. And we looked at a couple of examples like that where we don't have two intercepts. And that does happen. When does that happen? You have something like this. And you have something like this. But when don't I, or something like this. This method is less successful for these kind, and going through the origin. Yes?
What if it's just like, what if it's not even, doesn't even go through?
Well, all lines, other lines are going to have x, y intercepts, aren't they? Think about it.
Yeah, but what if it's like,
The domain is different. I'm only doing this.
yeah.
So what you do is you graph what you can. See how I can see what they are? And maybe I don't draw my line until I get to where I need to go. So you still can kind of use it. You can. What? Yeah, so let's say this was my domain was just this piece. Can I still see what the rest of the line would be? I would just make this part dark and I would erase the rest of it. So I can still use my intercept method if I wanted to. You can. Yes, you can. All right, let's work though now with our I like how she's thinking that. Let's work with our all real numbers so we can get some of those other confusing bits out. If you're having a lot of trouble with this, I find this making a little table can help. You make a little table like this, an x and a y table. It looks like the one we used before. In one place, make the y 0. In one place, make the x 0. So our x-intercept is the one where the y is 0, and the y-intercept is the one where x is 0. It's the same effect, but it just helps you see what you need to do. So 2x plus 7y equals 0. If y equals 0, then plug that in. Oops, it was 28. And this is the same thing, right? Didn't we just do this? The 14 is what you get when the y equals 0. Then you can set up this one where the x is 0. And again, same thing, we just did it. You get the same equations, but it just helps us maybe to see them and how to set it up. Can I see my x-intercept now? 14, 0. Can I see my y-intercept? 0, 4. So I have a little table here in the middle of the page. Some people find this a little bit easier when they first get started with x, y intercepts to make that little table. It just helps them set up the problem, right? You okay?
Yeah.
Yeah, okay,
You
sure.
have to use this thing, like,
Hmm?
this is gonna be like, we're gonna give us worksheets and we're gonna have to use this thing.
If you don't need this table, you don't have to use the table.
With the intercept.
You have to know the intercept method, yes. Don't fight it. I'm telling you, this method is actually easier in some cases than the next one we're going to learn. I do actually use this a lot. So don't be afraid of it. It's new, so you're a little wary. It's okay. These are the U-tries. Let's just do one together, just as kind of review. You can use the table or not use the table. But 3x plus 2y, the linear equation, right? So it's going to graph to a line. I usually do this. I say my x-intercept is x0, and my y-intercept is 0y. I found half of the coordinates already. So all I need to do is find the x. So I put in 3x plus 2 times 0 equals 6. My y is 0. 2 times 0 is 0, so it goes away. And I get 3x equals 6. So what's x? 2. X is 2. Let's do the same one for my y-intercept. My y is the one I don't know, but I do know my x. is 0. And I'm getting 2y equals 6, y equals 3. So what's my x-intercept? What are the coordinates of the x-intercept? 2, 0. And what are the coordinates of the y-intercept? 0, 3. I mean, that's really it. We got a lot of explanation for something that should be relatively easy. Questions so far? Yes, ma'am.
So on the first one, it's like my x goes to 0 equals to 10.
Okay.
Oh,
Right, so the 0, that's why we're choosing these, because 0 just takes stuff away. It makes it easy. Yeah.
for number 2, I have like, if we try to have x-intercept, you would make y from 0, right? And
Yep.
and then maybe divide that 4, so it would be 2.5.
Okay, yeah. She worked ahead. Here's my little thing here. She went right to decimals, because that's what you guys do that, right? We love decimals.
No.
Don't go to decimal. Keep it a fraction. The third method needs a fraction. It has to have it. So we are not going to go to decimal. We'll do this one. She said, listen, this one is x0. So that means that y is 0. So I plug that in. So that means 2 times 0 went away. I got 4x equals 10. And now we get afraid. Who's afraid? Anybody frightened? Look, yes, frightened. I knew it. She looks it. This is worse than Halloween, right? Because here we are. You have to divide. Look at that. And oh no, I have 10 over 4.
Simplify it.
Simplify it. What do you get?
5 over 2.
Come on.
More.
Yeah, what's so hard about that? What? That's it. Yes. What? Yeah, so you estimate. Now you have to have a little bit of number set. You call that number set. 1, 2, 3, right? What number is that? That's 2.5, right? Just guess where it is. Isn't 5 dash 2.5? Yeah, you just guess. You put it in between. All right, you do the rest. You do the rest. So we're convinced we think this is easy. You cover up this one. 5y equals negative 18. Cover up that one. Okay. So graphing using the intercepts. So really, it gets easy. Trust me, it gets easy. And now I'm going to graph. It's very simple. I've got 2 points. I'm going to actually have to count by 2s here. I'm counting by 2 so I can fit on my graph here because my x-intercept is 14, 0. And my y-intercept is 0, 4. Plot those 2 points. Connect them. I'm putting arrows in both directions. It does not say what the domain is, so assume that the domain is all real numbers. Easy peasy. Done. Right? I don't have to go and plug in 5 different points. I got it just like that. Let's see. Let's try this one before we go. Where is this guy? This guy's on the back. On the back here. So I've got graph the equation x plus 2y equals 4. So if I can find x-intercepts and y-intercepts, I'm good. So x-intercept, that's the one where the y is 0. So x plus 2 times 0 equals 4. Well, what's 2 times 0? 0 is gone. So what's x? 4. So what's my x-intercept? 4, 0. Y-intercept, that's the one where I know the x, but I don't know the y. So 0, y. So I'm going to plug the 0 in where I see the x. Well, that just makes it 2y equals 4. What's y? 2. So what's my y-intercept? 0, 2. Well, now we just go ahead and we just graph those 2 points. Graph those 2 points, connect them with the arrows. We're working with an all real number domain. Voila! Now I tell you, was that hard?
No.
Does it go fast once you kind of figure out what you're doing? Is it faster than what we did the first method? Yes. So is it worth learning? Oh, she still says no. No! I'm set